One thing about specific latent heat, whether it is for fusion or vaporization, we could find out more about the system or the mechanism behind it. This one changing to this form, okay? So if we look at we zoom this up, we look at the molecular level, okay? All the molecules are very much attached to each other, bonded by some kind of intermolecular or interatomic force, okay? So the heat they provided is to break the bond, okay? Is to break the bond, not really break the bond, because in water form there's still some kind of form involved. So basically is to weaken the bond between particles in solid, weaken the bond. So the energy required to weaken the bond is used up, and it was never meant to heat up the temperature of the system. It was never meant to make the particles moving even faster, increasing the kinetic energy. Okay, it's not meant for that. So the heat is basically meant for weaken the bond. So the water molecule still has some kind of weak bond between them, not completely cut off. Okay, but what if this one would change to gas vapor? So changing to gas vapor, the bonds are even weaker. Sometimes some of the bonds are to the point of breaking. Okay, but you see that this H2 required is somewhat higher, because if you look at the beaker, not only you need to weaken the bond between water molecule or water atoms, you also need to overcome the atmospheric pressure. Okay, you need to overcome two things. The heat is to overcome to weaken the bond between water molecule, and water molecule, when it needs to rise up, it has to face another force, which is atmospheric pressure. Okay, so basically there's no change of temperature for both fusion and vaporization. Okay, so that's why we have a graph like this that shows that, you know, this one going up and then here. So from 0 to A to B to C. So this is a melting chart. Okay, so the melting chart O to A is basically perhaps this one starts with -5 Celsius. So you heat up, here is 0 Celsius. And at 0 Celsius, this point is the point of interest for us, because even after some time passes through, there's no change of temperature. There's no change of temperature. A to B, there's no change of temperature, even though there's a change of time. Maybe this is 5 seconds, this is 10 seconds. So 5 seconds to 10 seconds, there's no change. And after that, B to C has changed completely to water. And here perhaps is water plus solid coexist. Half of this and half of that maybe. Okay, so here is completely a cube of ice. As for another chart, you know that, you know, the same thing. If you can have this one, and this one is perhaps 100 Celsius. So this point of DE is actually no temperature changes, because the heat contributed by an external source such as a heater is meant to weaken the water molecule bond and also overcoming the atmospheric pressure. So here is water, here is water and gas, and here is basically gas. So this is something about specific latent heat of fusion and vaporization. This one is the absorbing part, absorbing heat. Of course, there's another chart of going down for both, which we will discuss later.